All right, so here is the quiz that we worked on a couple times, and this is the first half of the unit, so it's really important that we get this stuff down before we have our test coming up next week. So I'm going to switch between versions as we go through this. So I'll start out with version A, and then I'll scoot on down to different versions as we move through each of the problems. So what I notice here on this first problem is that I know the side angle side of the triangle, and so the angles adjacent to the sides that I know. So I'm going to use the law of cosines. Cosine is our adjacent tool. So law of cosines, if I write it out with all its letters, looks like this. And so if I use the numbers that are given in the problem, I have 24 squared plus 34 squared minus 2 times 24 times 34 times cosine of the angle in between them equals c squared. And so the letter C is going to be this side length right there. Everything on the left side of the equation I can just type in. So I'm just grabbing my calculator, typing everything in. And just use parentheses how I wrote them. Make sure your calculator is in degrees, and everything should come out okay. So we have 395.14 equals c squared, square root of it. So we get 19.88 is approximately equal to c. So I took the square root in this step right here. Okay, so now we have all three sides and we've got one of the angles. If we want to find another angle, we could use either law of cosines or we could use the law of sines. If we're going to use law of sines, we just got to be careful that our angle measurements that we get actually match up with the side lengths. So let's go through law of sines and see what happens. So I'm going to set up sine of 35 over 19.88 because 35 is on the opposite side of the triangle. So it matches up just like how I matched up the cosine of angle C with the c squared at the beginning. Same idea here. Let's just call this angle B. Sine of angle B over 24. In order to solve that, I'm going to multiply both sides by 24 and type in all of this junk right there. So 24 times the sine of 35 divided by 19.88. So if you look right here, notice I have parentheses around my angle. So I typed it in with parentheses around 35. So I get 0.69 equals sine of B. And then I do the inverse sine of the answer I just got. And so I get that B is approximately 43.82 degrees. Okay. Now I want to double check that that matches up in the pattern. And the pattern is that your biggest angle should be opposite your biggest side, your medium angle opposite your medium side, your smallest angle opposite your smallest side. And so I'll find out what the third angle would be, which I guess is going to be called angle A. So the third angle is going to be 180 minus 35 minus 43.82, because triangles always add up to 180 degrees. So we get that angle A is 101.18. That does match up, that the biggest angle is opposite the biggest side, etc., etc. So I'm going to go with this as the correct answer. To find the area, we can use our formula 1/2 AB sine of C, which in this case we already know the A and the B and the C angle. We can just type all that into the calculator. 1/2 times 24 times 34 sine of 35, and you get 234.02. So that's it for question A. So I'll slide on down to version B to work on the next problem. On version B, I can't use law of cosines because I have angle, side, angle. Angle side angle is not going to help out, but with log cosines at least. But when I know two angles, I could find the third angle by subtracting the known angles from 180, just like I did to finish the previous problem. And I get 69 degrees. So now I know that this angle here is 69 degrees, and I can set up law of sines. Sine of 69 over 21 equals sine of, I'm just going to use one of the other ones, and I'm going to call this side x. Sine of 37 over x, because those are opposite of each other. Some people like to just flip both fractions over, or you can cross multiply and then divide to solve for x. So I'll cross multiply because I think that's a little bit more familiar of a technique. So x times sine of 69 equals 21, times sine of 37. So then you just divide by the sine of 69, and you should get your x value. You can type this into your calculator as long as you remember to put parentheses around the 37. So 21 sine 37 divided by sine 69. X comes out to be 13.54. Now I've got a couple choices because I know the x value, and so I have two sides and an angle, or I have two angles. I could do law of sines again. I kind of just like to do law of sines twice because it's familiar. I mean, I just did it a second ago, so it's easy to do it another time. I'm gonna call this side y. We'll flip everything around, and we'll get y equals 21 sine of 74 divided by sine of 69. And it's really nice too because you can take what's already in your calculator and just change the 37 to a 74, and it'll work itself out for you. So y is 21.62. Then I'm going to find the area. So 1/2, and then I just need to find whatever two sides I want and the angle that's in between them. So I'll just use 21 and 21.62. So that's using this side and this side. So I have to do sine of 37 and just type all that in. 1/2 times 21 times 21.62 sine of 37. And the area comes out to be 136.62. So that's it for questions 1, A and B. Now I'm sliding on down to do question 2. If we have a pizza here and we find one slice, we're really finding the area of a sector. And the area of a sector is whatever your angle is in the middle. I usually use the letter theta. It just looks like a 0 with a cool comb over. The area of a sector is just, well, a circle is pi r squared, but we don't have a full circle. We really just have theta out of a full circle. So theta divided by 360 times pi r squared. But really, this theta over 360 just represents the fraction of a circle. So some people on this first problem here, where it says 10 slices, they figured out, okay, 360 divided by 10 is 36, and then they did 36 divided by 360. But you can just sort of skip that first step and just say, oh, well, if there's 10 slices, then it's 1/10 of a full circle. So times pi times r squared. You might be wondering, where did the 10.5 come from? Well, I told you in the problem the diameter was 21, so I had to cut it in half. If you figured out that it was 36 degrees and then did 36 divided by 360, that's totally fine. It comes out to be the same thing as using 1/10. So I get 34.64. Part B is just using a 30-degree angle. So we just go 30 over 360 times pi times 10.5 squared. And that's just typing it into your calculator. Oops. There we go. Comes out to be 28.86. There we go. Great. All right, sliding on down to another version for question 3. A couple different ways to do this. A lot of you tried cutting it up into rectangles and triangles. That's an okay technique. The idea I was hoping you would notice is that this is really just asking you to find the area of the bottom triangle and the top triangle. So the area of the bottom triangle is just 1/2 AB sine C. So 1/2 times 8 times 24 times sine of 60. The area of the top triangle is just 1/2 times 16 times 8 sine of 120. And you just add those up. So 1/2, I'm going to type it all in as one long thing. You can see how I typed it all in there. Just one long line. Ends up being a total area of 138.56. And then the last one on the quiz was finding the shaded area. And what I hope you noticed on this one is that the shaded area is in between a triangle and the edge of the circle. And so what you want to do is do the sector minus the triangle. So the sector is 50 degrees divided by 360 times pi times r squared. And the triangle is 1/2 times a times b sine of c. And again, this is just something you can type in the whole problem directly into your calculator, all as one long line. So here's how I typed it in. And then I hit enter, and I get 0.21. So there you go. That was the whole quiz. Please comment or talk to me in person if there's anything that was confusing. Thank you for watching.